Hi students, I am Sheeba, EC department from Emmanuel Arsar JJ College of Engineering. Today we are learn about the topic intermodal dispersion. The intermodal dispersion arises due to the variation in the group delay for each individual mode at a single frequency. When the group velocity of different mode varies, the group velocity will be formed. This distortion is available in multi-mode fibers. The maximum pulse broadening arising from intermodal distortion is the difference between the travel time T max of the longest ray concurrence path, that is highest order mode, and the travel time T minimum of the shortest ray path, that is the fundamental mode. A signal distortion effect in multimode optical fibers. It happens because different light rays take different path through the fiber core. That is, inside the fiber core, the different light rays take different path. Next, rays traveling straight down the center arrive first. Rays bouncing at steep angles take longer path and arrive later. This time gap spreads out the light pulse. So this is called intermodal dispersion. Next figure shows the intermodal dispersion. Here intermodal dispersion, light rays propagate through different paths, hence their reaching time at the destination is different. The causes and the impact of intermodal dispersion. First one, multiple path. Light enters the fiber at various angles, creating different path length for each mode. Second one, pulse spreading. Arrival time differences stretch the signal pulse over time. Third one, data limits. Overlapping pulses cause errors and limit data speed over long distances. Next is how to reduce the intermodal dispersion. First one, we use graded index fiber. That is, it changes core refractive index smoothly to make all modes travel at similar speeds. Next one, single mode fiber. It uses a very narrow core that allows only one light path, removing intermodal dispersion completely. Multimode step index fiber. Step index multimode fiber is a type of optical fiber featuring a large core with a uniform refractive index and an step-like drop in refractive index at the cladding boundary. It allows multiple light rays to travel simultaneously, sharp total internal reflections. It allows multiple light rays to travel simultaneously, sharp total internal reflections. Next figure shows the diagram of step index multimode fiber. In here, inside the core, the wave travels at different light path. First, we can let the core refractive index N1 and the cladding refractive index N2. The core diameter will be A. Next, the structure and working principle. The structure, the step index fiber consists of core and cladding. The inner core has a constant higher refractive index. The outer cladding has a lower constant refractive index, creating a sharp step change at the interface. Second one, light path. Light beams enter at various angles and bounce down the core in a sharp zigzag path governed by total internal reflection. The key characteristics of intermodal dispersion: large core size, that is typically ranges from 50 micrometer to 200 micrometer, making it easy to couple light into the fiber from cheap sources like LEDs. Second one, high model dispersion. Because different light rays take different path length, they arrive at the receiver at slightly different times. This pulse spreading is called model dispersion. Third one, low bandwidth and distance. Severe pulse overlapping limits the data rate and restricts usage to short distances. Fourth one, low cost. Simple manufacturing makes components and electronics relatively inexpensive compared to single mode or graded index alternatives. Next is the common applications of step index fiber. First one, short distance local area networks, that is LAN networks. Second one, medical optical fiber based illumination and sensing. Third one, low speed short run data links. Next is multi-mode graded index fiber. A multi-mode graded index fiber is an optical cable where the core's refractive index decreases gradually from the center out toward the cladding. An optical cable where the core's refractive index decreases gradually from the center out toward the cladding. This continuous change bends light rays into smooth sinusoidal path, making all modes travel at nearly equal speeds to reduce signal distortion. Next, the diagram of graded index fiber. Here, the fiber axis is along the center of the core. Inside structure is called core and the outside is cladding. In between the core and cladding, the air is passed. The diameter of the core is 2a. Next is the core structure and design. First part is core center. It has the highest refractive index value. Second one, outer core. That is, index drops smoothly to match the cladding edge. Third one, profile shape. Usually parabolic or refocus light continuously. Next one, core size. Typically 50 micrometer to 62.5 micrometer wide. Next is how light travels inside the multi-mode step index fiber. First, rays near the edge travel faster through a lower index. Second one, rays near the center travel slower through a higher index. Equal race times keep light pulses sharp and clear. That is, the equal light pulses are better to travel. Next is the advantages. First advantage is low model dispersion, that is much better performance than step index fiber. Second one, higher bandwidth. It supports fast local data networks. Third one, more costly, harder to manufacture than simple step index class. Finally, we can conclude the topic. So thank you, students.